Hello my dear students, after complete and healthy discussion on periodic table portion and in that previous video lecture we learnt that how we can remember those 118 elements in the periodic table, and in our previous video lecture we discussed or we made our concept in four different way that we can learn separately for those S block, P block, D block and F block elements. We used some trick, some shortcut, so you can revise your knowledge, your concept again and again by watching those videos, correct? So it was first portion of the periodic table. Now second portion of the periodic table chapter is trends in properties or periodicity in property, and for first property we will talk like valency and valence electrons. So students, valency and valence electrons are very common, and actually it is very easier than any concept, correct? So first of all, what is valency, and then we will discuss about valence electron. So valency is nothing but it is combining tendency of the element in the compound, means how element combined so that they will form compound. And next is valence electron. What is valence electron? Outermost valence cell electron. So valence cell, here hydrogen, lithium, sodium, I took some example, and in this example we will first of all we will make electronic configuration. Electronic configuration means K, KL, KLM, KLM and shell is as per the availability of accommodation of number of electron in that particular shell. K shell, it can occupy maximum electron 2. Next is L cell, maximum occupancy of L cell is 8. For M cell it is also 8, and further it is N. N can be accommodated 18 elements or 18 electrons. So for hydrogen, lithium, Kl, sodium, Klm. For 1 electron, so I will use 1 cell. More than 2 electron, I will use 2 cell, and more than 10 electron, I will use 3 cells. And suppose there are more than 18 electrons, so at that time I will use 4 cells, that are K, L, M and shell. So one by one we will discuss in detail 1 to 20 elements. So for hydrogen, valence cell is K, for lithium valence cell is L, and for sodium valence cell is M, correct? Remember students, outermost cell is known as valence cell. Okay, so for hydrogen it is only 1 cell, that means K cell is also inner cell as well outer cell. L cell is outer cell, K cell is inner cell. Here M cell is outer cell, but K, L cells are inner cells, correct? And again one thing is there, valence cell electron. So for hydrogen, in K cell only 1 electron, for lithium in L cell 1 electron, and for sodium in M cell 1 electron. So for all these element, means hydrogen, lithium and sodium, valence cell electron will be how much? It will be 1, correct? So I took first 20 elements and their electronic configuration, their valence electron and their valencies. So hydrogen to calcium. And in my another video lecture I discussed that how we can learn first 20 elements directly without any problem. So you have to see at least, you have to watch at least once that video, so that you will be comfortable with first 20 elements, correct? So hydrogen atomic number 1, serial number is also known as atomic number, and for nitrogen atomic number is 7, and for calcium atomic number is 20, correct? So as per the accommodation tendency, means hydrogen can occupy maximum, hydrogen has maximum kitna electron? It is 1 electron, and it has K cell only. Then K cell can occupy maximum 2 electron. That's why for hydrogen it is 1, and for helium it is 2. Suppose more than 2 electrons, so I will use Kl cell. Lithium K2L1. Similarly for nitrogen K2 and L5. For fluorine K2 and L7. For neon K is 2 and L is 8. The sum will be its atomic number 2 plus 1 3, 2 plus 4 6, 2 plus 6 8. Correct? The sum of the electron will be its atomic number. Remember students, right? So as we proceed 11 number elements and here electrons are more than 10, then we will use another cell, that is KLM. So for here maximum electron in K cell 2, maximum electron in L it is 8, and maximum electron in M further it will be 8, but we have 11 electron. 2 plus 8 is 10, and 1 it will be for M shell. Similarly for phosphorus, see KLM, phosphorus atomic number 15. So maximum electron in K shell it will be 2, 8 in L shell, and remaining 5 will be occupied by M shell. Last, suppose argon. Argon has atomic number 18. So we will use 3 shells. For K cell it will be 2, for L shell 8, and last shell, that is M, it will occupy 8 electrons. But as we move for potassium, there are 19 electrons more than 18. So in that case I will use 4 cells KLMN. So K2, L8, M8, and next N is 1. And for calcium it will be 2882. So I think this concept is clear, students. Just remember, maximum occupancy of K cell is 2, maximum occupancy of L cell is 8, maximum occupancy of M cell is also 8, and that for N cell it will be 18. So as per the filling occupancy, I can assign exact number of electron in that shell. So here suppose it is nitrogen atomic number 7. So for 7 I will use 2 cell, because maximum occupancy of K cell is 2, and remaining electron will go into L shell. Okay, that is 5. Suppose silicon 14. So maximum occupancy 2, L can occupy maximum electron, that is 8, and remaining electron will go to the M shell, that is 5. So I think this electronic configuration is clear to all. And next is valence electron. So I made some trick. See, 1 2 1 2 3 4 5 6 7 8, again 1 2 3 4 5 6 7 8, and 1 2. So just remember, first 2 elements has valence electron 1 2, and last 2 element has valence electron 1 2, up to 20 elements. And the middle portion 1 2 3 4 5 6 7 8, and next from sodium to argon it is 1 2 3 4 5 6 7 8. So it is very easy. And last electron you can choose here 1 2, here 1 2, and here 6 7, see here 8, here again 2 5 7, something like you can manage by your own. Correct? Now it's time for valency. For valency we will use 2 jugaad, 2 trick, 2 formula. If valence electrons are equal to or less than 4, then valency is nothing but number of valence electron. Correct? And if valence electron more than 4, then we will use valency equal to 8 minus valence electron. See, for hydrogen it is valence electron 1, so valency will be 1. For helium it is exception, because noble gas can't combine to form compound because of their inert nature. So only one exception we will use, rest it's okay. Correct? So for lithium valence electron equal to 1, so valency will be 1. For boron valence electron are 3, so valency will be 3. But for nitrogen, see, when we will go to the nitrogen, here valence electron are 5. So valency will not be equal to 5. It will be 8 minus 5. What is 8 minus 5? So answer will be 3. For fluorine, see, for fluorine valence electron are 7. So valency will be 8 minus 7, answer will be 1. So students, if valence electrons are equal to or less than 4, we will use valency equal to valence electron. But when valence electrons are more than 4, means 5, 6, 7, 8, at that time we will subtract that value by 8. See next concept, that is for phosphorus. Valence electron are 5, so valency will be 8 minus 5, 3. For aluminium, valence electron are 3, so valency will be 3. Okay, so it is very common and very easier, and it is understandable also, correct? So in next video lecture we will talk about another periodic property, that can be atomic radius, metallic radius, electronegativity, etc, etc. So we will again meet, and in our next video lecture we will discuss and we will clear some doubt also, and by using the certain videos by which we can understand our upcoming concept. So till then, thank you, thanks a lot.